Now we've gone through yes, we can install it. Yes, we can image it. Yes, we can create some disks. Now we're going to talk about file systems for a few minutes. And you've used this file system before. NTFS is the one that you should use unless you've got a real good reason to use FAT. The FAT file system doesn't really have any security at all. You can share it, but you can't really control with any degree of granularity, I guess is the word, who can actually access anything. For instance, because we use NTFS, when you go to your home directory, can you see your home directory? And I hope the answer is yes. But can you get into anybody else's? You actually probably can't see them if you just go to the share, and we'll talk about shares here in a minute. The share allows you to see it across the network. So what we want to do today is look at actually managing who can have access to resources. There are a couple of terms that are kind of unique or specific. They're not really unique, but are specific to Windows. We're going to talk about rights and permissions. Rights are basically what you can do to the desktop. Do you have the right to add hardware? Do you have the right to change the background of the machine? Do you have the right to put in a static IP address? Permissions are the ability to use resources. Do you have permission to get to your home directory? Do you have permission to use a particular printer? So rights and permissions are two terms that frequently, honestly, get used interchangeably, but specific definitions, rights are what you can do to the machine itself, to the hardware. Permissions are the ability to use a resource. Can you get to a file? Can you get to a folder? Can you use a printer? Kind of deal. And if you ever do any netware, and I think it's just about gone forever in the U.S. anyway, what Microsoft calls permissions, they call rights. So we'll not go there, but just so that you've got that one. The file system features and limits in Windows 7. It has the ability to create FAT file systems, and now they got a new one called XFAT, which is the FAT file system in it. File system management tasks and the file system management tasks, who can use what? Can we limit, and yes we can, how much disk space each individual can store with the disk management tools, so we can set quotas on who can store things, how much can be stored. And I think that you have a limit, relatively large limit, but there is a limit on your home directories, or at least there used to be. Used to be like a 250 meg when we didn't have a lot of disk space, but more disk space, more storage space. If you have somebody at your house and you make them a user, and you want to limit what they can actually put on your computer, how much stuff that they can store, kids, for instance, or download and everything, maybe, you can do a disk quota. So you can use disk quota in the NTFS file system. When we talk about all these things that we can do, that capability is only available in NTFS. FAT basically is just there. There's no limitations, no anythings to them. Folder attributes used in FAT and NTFS file systems. Folder attributes and file attributes are going to be very similar. But in FAT, the only thing we're going to have are folder attributes. And the only attributes we're going to have will be what we're going to call share attributes. And when we share something, that gives users on your network the ability to actually see that thing across the network. We'll look at some of that. File and folder permissions, the scope of inheritance, plus the impact of ownership and moving or copying content. That's a mouthful, and what's that really saying? File and folder permissions, we'll look at those things, and file permissions and folder permissions are basically the same, except that you can't create something in a file and you can't create something in a folder. You can put a new file in a folder, but you can't put a new file in a file, obviously. Folder, I guess, kind of think about it as a container. Permission and scope of inheritance. The permission scope of inheritance, as you go down the file directory structure, permissions are inherited by default. You can turn that off. And what we'll look at, and I want to hopefully demonstrate some stuff here if you have inherited permissions, you can't take them away until you make them actual permissions that you give, discrete permissions. But we'll look at that and how you take that away, and you can copy them or do a number of different things. Ownership and moving or copying content. The impact of ownership, we're going to do the whole lecture here. The impact of ownership is if you own it, you can give permissions. One of my favorite things to do, and this actually happened to a student a few years ago, is take everything away, including read from everyone, and you double-click on the folder and it says you can't get there. But you don't have permissions, but since you're the owner, you can give permissions. And if you're the administrator, you can take ownership. You can't give ownership away, but you can take ownership. The story there was we had a student, and they were upgrading, going from one version to the other, and this was like 2000 to 2003. So they backed up their payroll and their old domain and put in their new domain and restored their payroll, and lo and behold, nobody could open the payroll database, so nobody can get paid. That's pretty serious. What was the issue? It took the permissions from the old domain, and in the new domain, different users. Somebody had to restore that database. Somebody had to own that file, and that was the administrator. The administrator owns the file. Just go in and give permissions to the users that you want to because you are the owner. So I think it's kind of an interesting exercise to just take everything away and no, it doesn't work. But since I own it, I can give myself back permissions in those things. Moving and copying content. The answer here is they're going to have a whole bunch of one. I'll say it again when we get to the slide. When you move or copy, you inherit permissions in every circumstance except when you move it to a new volume, a new drive letter, a new drive letter, a new volume. So it inherits the permissions every time except when you move it to a new location, a new volume. What you do when you move something on the same volume, ever notice that when you move things, it's a lot quicker, it's like instantaneous, and when you copy it, if it's a big file, it takes a long time because you actually have to copy it. When you move something, the only thing it does is change the pointers in the directory. So all the permissions are going to stay the same. When you copy something, my little pea-brain, think about it going through the folder itself and picking up its permissions there. So it's going to inherit whatever happens there. The previous versions of files, previous versions has been around for some time on servers, in shares. It's been really, really specific. What this does is if you create a file and do a save as, and then all of a sudden you decide that, no, you really didn't want to wipe out the old one, and this is not going to be, okay, I've created it, now I've got a version right now. This happens on a regular basis. You can go back and get the previous version, restore it, or copy it. So just because you overwrite a file now doesn't necessarily mean that it goes away. It may have gone away, but it doesn't necessarily mean that it has gone away. So the file systems, you've looked at that in the DOS class. What does the file system do? Organizes the disk so that we can put stuff in and get stuff back out. We can always put stuff in. If we can't get it back out, it's not a really good deal, is it? I mean, I do that all the time. I have bunches of things that I save. Anybody do that? If I throw it away, I'm going to need it, and I know I don't have it. But if I put it someplace, I've got it, but I have no clue where it is. Does that happen to anybody but me? Systems organized, I'm just talking about individual things, but files themselves, and organizing the file system, where do you put things, that is always a handy thing to do. The search function that you have now really is pretty good. The indexing function, because it will index and make an orderly search for things, works pretty well in this system. So it supports the 4 systems, FAT. Been there, done that in DOS, right? File allocation table, FAT16, FAT32. FAT32 obviously is the one that's used mostly now. The NT file system, NTFS, New Technology File Systems, what the NT stands for is New Technology. It's so new it's been around since the 90s, the 1990s, so we can say since the last century. Different versions of it. NT 4.0 had the NT 4.0 file system. Windows 2000 had the NT5 file system, so we just keep changing the versions, more functionality. You do run into a situation that you don't necessarily have backward compatibility with these things. So, but the only time, again, that any of this applies is if we're dual booting the system and we're trying to read directly from the disk. If you're going across the network, not a problem. It uses a different protocol to do that. The universal disk format, CDFS, UDF, and CDFS are mostly used to access removable media. And then the extended file allocation table, very similar to the FAT. What it is just supposed to be a more efficient version of FAT that goes into this one. So it is FAT. You have the ability to do those. Earliest file system, MS-DOS. How many storage locations do you have in a FAT16 system? This is that number I told you just keeps coming back. What's 2 to the 16th? Oh, yeah. 65,586, right? 2 to the 16th. That's a number that just never goes away. It is also for a Class B network, right? See how we work that one. FAT12, pretty old. A lot of floppies use FAT12 and FAT17. FAT16 and FAT32. And this is the versions of FAT. What we have here, actually they use FAT12, they didn't use 17. They use FAT12. FAT16 and FAT32, 2 to the how many storage locations is what we're really talking about in any of those. FAT32, 2 to the 32nd, you get a whole lot more storage. The capability goes up a lot further. The thing that you've got to look at right now in memory, not storage, but in memory, is whether you have a 32-bit and the 2 to the 16th is why I got there, 2 to the whatever. A 32-bit or a 64-bit operating system as to how much memory can go into it. You're constrained to, and I know it's less than that, it's like 3087 or something other, but the theoretical 4 gig in a 32-bit system. 64-bit system, you get a lot more, and that's going to become a function of the BIOS and the operating system combined. FAT limitations, limited fault tolerance. What that means is, regardless of what we do with this basic or dynamic disk, convert it to dynamic. If it's FAT, you can't create a RAID, a software RAID, with a FAT system. Inefficient storage and limited security. Inefficient storage, did you guys look at what happens to the wasted disk space in DOS? It's huge. If we had, I don't know what, 16K, we'll make up a number, 16K clusters, and you had a bunch of 1K files, each of those 1K files takes 16K of storage. So there is no ability to really shrink that, and the clusters are dictated based on the disk size. The larger the disk, the larger the clusters in it. Limited security would be limited to none. That's a little harsh. You can get share security if you access it remotely, but if you'll think back to the FAT systems that you may have used, Windows 95, Windows 98, and maybe if you were unlucky enough, Windows Millennium, when you logged on to the computer, could you limit who could see any of the files on the computer? No, it could see everything. That's why there is no security in it. In the NTFS file system, we can limit who can see both remotely when you access it across the network and locally when you log into the console. Trying to work in some terminology here, so when we get to that, when we talk about remote and local files. Console, when they talk about consoles, when you're actually logged onto the computer, that's going to be a console connection. The FAT benefits, legacy operating systems. Yes. Honest, way back to when, the only thing that comes to mind, if I needed a FAT file system, if I dual booted something with Windows 95 and Windows 98, and the odds are against that, are they not? Or in the server sense, if I dual booted something with an NT 4.0. NT 4.0 only recognizes the NTFS 4.0 file system and the FAT16. It does not recognize FAT32. The 32-bit FAT was after it. They never went back to fix that. And unless you've got a really good reason, NTFS FAT should be something that you only do when somebody asks you to do it on a practical exam. If you've got a really good reason to use it, that's it. And the only really good reason that I can think of is that if you're dual booting a system with a really old system that only recognizes that file system. It's the only common file system. Are simple, suitable for removable media, and it will be removable. It will be typically what's unremovable. Oh yeah, that's the other reason I can think. If you want to take your removable hard drive and plug it into a Windows system and plug it into an Apple system, they both recognize the FAT file system. The other thing that you might run into is the maximum FAT16, FAT32, and the reason is I was thinking that a couple of guys are sitting back there where Tanisha and Josh are. We're trying to do a backup on a big USB hard drive, 250 gig hard drive. 250 gig was big at the time. It was before we had all these cheap terabyte machines. And they were trying to back something up with a backup single file. It was really big. So it won't save, it won't save, it won't save. Why won't it save? Because it's formatted for FAT16 and you're beyond the maximum file size. They changed it to a FAT32 because they want to leave it in a FAT file system and they could save the file. But those are the kinds of things that will get to you when you start using all these file systems. Again, unless you have a really good reason, use the NTFS. Most flash drives are formatted for FAT because NTFS actually has a much larger overhead. I think that, I don't remember if it's in this one, it probably is, and I'll make myself silly, but 250 meg is basically the absolute lowest that you want to go with FAT. Otherwise, the overhead from the file system itself is going to take up all your disk space. NTFS first introduced with Windows NT, and again, that goes back to the last century, to the late 90s. NT 3.5 and NT 4.0 was the one that most people were using. It actually was fairly successful. 3.5 had some issues. NTFS partitions theoretically limited to 256 terabytes. But we said, no, that was the other class. But the practical limitation in Windows for NTFS is 2 terabytes. If you go above that, there's another file system that will take over. It works the same way as NTFS, but it's designed to manage large partitions, large volumes. And it'll happen automatically. We say, oh yeah, you've got to pick it. If you don't pick it, it'll pick it for you if you go above 2 terabytes, because NTFS, even though it has theoretically goes above that, it really doesn't.
What is the limitation to FAT32 then?
I don't remember off the top of my head. About 2 to the 32nd storage location. Depends on the cluster size. And the default cluster size, I think, in FAT32 is 4K. The cluster sizes change, and you can specify the cluster size, by the way, when you format with a FAT32. There are limits, but you can specify something larger than the 4K cluster size. The 2 to the 32nd are storage locations, the number of clusters that you can have. So you take the number of clusters that you can have and multiply it by your cluster size, and that's going to give you your disk size. It's fairly large. We're talking in I think, terabyte region. 32 gig? Okay, 32 gig. We're not in a terabyte. 32 gig. Stores files similar to FAT. The data is secure, reliably managed, and allowed to grow. So the data is secure. We can give permissions, and we'll look at permissions. I've got some permissions exercises for you to do when you do that. There is a permissions exercise in the homeworks. It's not graded, but please do it. I think that after we talk about that, once you work your way through that, some of this terminology will be clearer, hopefully. The advantages: log file and checkpoint consistency, automatic bad cluster management where it consistently checks and doesn't use the bad clusters. Transactional NTFS files are stored in Unicode and 8.3 DOS format, more efficient storage here. Alternate data streams, which is kind of an interesting thing, and it's really good for all you hackers. What it does is allow you to store a file, hide a file in a file. Kind of interesting that it's there. What you do is instead of storing your new file in the data area, you actually store it in the directory area. And it really doesn't change the file size. Kind of interesting, but put a file in a file, alternate data streams in here. Encrypted file system allows you to encrypt files. Encrypted file system, we have compression and encryption, and when we look at that, they've got like checkboxes. You can do one or the other. You can't compress an encrypted file, and you can't encrypt a compressed file. So even though it shows checkboxes, when you check one, it unchecks the other one. We can do one or the other. You can't encrypt, and when you do encrypt, you're going to create a certificate. When you get those certificates, please make copies of them, export them, and I'll go through that. It's a real pretty simple process. Because the system stores your certificate in your profile. What happens if you delete your profile? You delete your certificate. And you have these really, really well encrypted, fairly well encrypted files that are really secure because you can't get to them either. If you have a copy of the certificate, if you've exported the certificate, you can import the certificate and continue to use it for your encryption and decryption. So when you encrypt something, anytime you encrypt something, make a copy of the certificate, including the private key. And when you go through, and we'll do more of that in the security, including the private key, because the private key is what you really need for you to do the information with. Disk quotas and compression we can also do, file and folder permissions, and we'll look at that. That's a big part of NTFS, is being able to use file and folder permissions. All this other stuff, yeah, is really, really kind of cool. You can compress files. If you compress them, it's going to take more time to save them, and you can compress a directory, compress a disk. More time to save them and open them because you've got to do the compression and the decompression as it goes through. Disk quotas, how much space do people have? NTFS advantages: shrinkable and extendable partitions and volumes. We kind of alluded to that. If you put the whole operating system on the C drive of your virtual machine, that's okay, because now that you know how to use the disk management tools, you just go and shrink the partition, and then you'll have some empty space available so that you can do the RAIDs based on the drive layers. If it doesn't confuse you, you just have two other disks, that's okay, because two disks is all you need to do those RAIDs. But if you get confused about which ones you're doing, go ahead and shrink it so that it will work the way the book does. Mount points. Those of you who have had Linux have talked about mount points. Is that true? Have you guys talked about mount points yet? Yeah. What does a mount point do? It mounts something, right? What this does, and this is kind of handy if you're running out of disk space on a disk, what you do is make an empty folder, and it does have to be empty, and then you go to a new disk or wherever you have space and create a volume, create a partition, and say, I want to mount it to that folder. The way I think about that, and again in my pea brain, is the folder is like a doorway that goes someplace else, you know, into the black hole or whatever, so that you now can access the information through the original drive letter based on a folder, but you're not actually taking physical drive space from that drive. It's kind of a handy thing. This worked with basic disks back to Windows 2000 because Microsoft, gives you best practices, says you want to put it on a certain partition, which is probably, anytime you do that, at least double what they say and probably triple what they say, because Windows never grows, does it? Anybody ever look and see how big your Windows 7 partition is at home? These virtual machines just grow exponentially. Because what you started out with probably a gig. One of you has a 17 gig right now. That's huge. My virtual Ranger, which is a Windows Server 2008, with not a whole lot on it right now, its C drive is 92 gig. That's huge. They will grow, so always give yourself more space than they tell you. But if you run out of space, you can go into your C drive and create a folder there and have it mounted, or a different partition on a different physical drive mounted to it, and you can then put that information on C drive physically someplace else and recover some space. Sparse files, I don't know that that's anything really all that dramatic.
Can you not put that in a virtual drive?
What?
Mounting.
Yeah, you can do it in a virtual, and you will do it in a virtual drive. Okay. Yes. The only thing you really can't do in a virtual machine, there's a couple things. You can't do sound. And you can't do BitLocker. Well, because we don't really have access to the BIOS of the machine. But if it was physically on the machine, you probably could. But what you're using is someplace else. So that's why. If you had it on your physical machine with a sound card, you could do sound too on the virtual machine. So if you want to run virtual machines at home, there's a lot of software. Your MSDNAA account, you can get either the Microsoft variant or the VMware variant of the virtualization software. I've always used. We started out using VMware. It works great, but we found the ability to use the web page that you can use so that you can work on the machines on campus or off campus, and that's why we stayed with the Microsoft solution. The other reason to do that, once you get into the Hyper-V world, Server 2008 on up, is Hyper-V is free. VMware Server ain't free. So we've kind of tended to stay with the Microsoft virtualization for those reasons. And you get into one, you kind of stay with it, you learn as much as you can about it. You don't get into the I've got to now know 47 different ways to do virtualization. Although I will, Hyper-V, the new Hyper-V is pretty good, but the VMware has been consistently more efficient than the Microsoft virtualization answer. Information about files and folders are stored on the disk, kept in a special file called the master file table. If you go back to DOS, where was all of the information, the directory, and the FAT table stored? Where were they stored? Anybody remember? But where physically on the disk? 0, track 0, right? So track 0 got corrupted. What happened? Because you had 2 copies of the FAT, right? One stored right after the other on track 0. What happened if disk 0 or track 0 got corrupted? You lost your everything, right? The master file table not necessarily going to be stored there. It can be stored any place on the disk. So you don't necessarily have the track 0 issues with it. System files are hidden from general browsing. Yeah. NTFS file systems are protected by a transactional file system that allows us to limit who can do what with the file systems themselves. Can be rolled back to a known good state. Changes can be rolled back with the log and file check. That's kind of handy if you have something that has an issue when you do those things. And the bad cluster management keeps a record of all the clusters that are considered unusable. We could always do that with check disk, scan disk, right, in DOS. NTFS keeps track of what's going on with these things and won't use the bad clusters. Transactional, utilize the change logs and the checkpoints to validate that the updates have successfully completed. This would come in, honestly, if a system crashed and it went back and checked the logs out, this write's not complete. Linux uses the same thing with the same sort of system, as it checks to be sure that the complete change has been made before it says, okay, I can do away with this log file. Unicode characters in the file name, 2 names assigned to it, the long file name and the 8.3 file name. The 8.3 file name's got all the special characters, the truncated, but it also uses the long file names along with it. Alternate data streams, multiple data streams can create additional name streams and link them to a file. That sounds like it's a really cool deal, right? Till you say, maybe it's a really cool deal for a hacker. And it is a really cool deal for a hacker because you can hide something within a file within a file. So we could send you a virus that way, couldn't we?
So alternate and multiple are the same thing?
I'm sorry? Multiple streams, and the alternate is the file content is normally stored in the file content data stream. And the description of it, the directory information, permissions, and all that are stored in the file system directory stream. So there's 2 of them. That's the multiples. What you do with the alternate is instead of storing it in the data area, you store it in the directory area, the directory in the other location. It's still there. You can get it back, but it's hidden from view because it's in an alternate location, not where you would normally expect the information to be for the file itself. Kind of interesting, isn't it? And it's not a real complex system to do that. Encrypted file system can be encrypted to protect the information. Again, that's only on an NTFS system. When I first saw this, I said, oh, I know the answer to that then. If I move it to a FAT file system, it's no longer encrypted, right? Because you can't encrypt on FAT. They got that one figured out. You got to have the key in order to move it to the FAT file system to decrypt it. I thought I had thought of something. Well, yeah, right. But, yeah, if you move it to a FAT file system, you can't encrypt it, but you have to decrypt it to move it there. The other thing to consider from a security standpoint, this is only encrypted while it's on the disk. If you move it across the network, it's decrypted before it goes on the wire to go across the network. So if somebody is sitting on a hub, right, because they would see everything, and you're on a hub and everybody sees everything, you actually decrypt your data before you send it across so they could theoretically intercept it. And we have other techniques to encrypt that data, but it is not encrypted after it goes off the machine. File and folder permissions, access control lists, and these are the terminology. Each file and folder has its own. It determines the action. The access control list, who can actually do it. When you add the users, when you create a permission, it's the access control list. They have ACLs and ACEs. When you put somebody in it, that's an access control entry, the user that actually goes into the list itself. Can compress the files to save a compression and encryption. And disk quotas is the amount of disk space that somebody can use. You can set that, and they've got an exercise to do that. There's a couple things you can do. You can send them a message. You can log it. You can stop them from saving more information. So there is some flexibility as to what happens when you used up your quota in these things. It has to be. It's not on by default. You have to turn it on. Are not enabled on the NTFS partitions, and you can't do it on FAT partitions. All this clever stuff, you notice, is only available on NTFS partitions, not on FAT partitions. And the shrinkable, we've talked about that. Let's stop here and take a break, because I see that it's time for a break. Okay, continue. This is the window that you would get for the disk quotas. And what I want to do, brought that machine up. Let me see if I can get this machine back up and show you where you would go to do that. In your machine, and this is a server, should work the same way. Go to whichever volume. This is volume specific. Whichever volume you want to do this on, and right-click on it. I'm going to do the data volume here. Properties, and in the tabs here, one of them is quota. Click on the quota. You notice by default it is off. Click on it. Deny disk space, and this is where you can, what you want to happen to the individuals. And even after you turn it on, the default is do not limit disk, and then we can go in here and limit the disks to whatever we want. If you then when you get quotas, if you then want to provide exceptions, you can go in here to the quota entries and modify who actually gets the quotas, because by default it's going to do everybody but the administrator. And then you get some other choices down. So the quotas, previous versions, you notice, are also here. If we had previous versions, we could do that. And then shadow copies. Shadow copies is disabled by default. You have to turn that on. Shadow copies are, again, a service that allows you to get old files back, and they go on save it on a regular basis situation. But when you look at those things, that's where you would do quotas. They just went in there, and we had the, okay, here's what it looks like, there's where it looks like, and there's where you go to actually change it. And some of those other things. Volume mount points. I guess while we're here, might as well do one of those. Volume mount point, this is really a, let's see if I can figure this one out, huh? So what tool do you think I'm going to need to do a volume mount point? Command prompt? Yeah, but I'm not that good with disk part. So let's go to the disk management, which is in computer management, right? What did I say we needed first in order to do that? I've got some unallocated space. What do I need? An empty folder. So let's go to C and make an empty folder.
Hold on, let me catch up.
An empty folder, I'm going to call it something really clever like mount, so that I know what it is. It does have to be empty. The Windows 2000 book, I know you don't want to hear these things, but I'll tell you anyway. The Windows 2000 book had this lab to do this mount folder, and they had you go create a folder and put a bunch of stuff in it and say, now mount it. You can't mount it if it's got anything else in the folder. So we would go in here into the unallocated space, and we can't do that. Why can't I do anything in this unallocated space? Notice I got a little red arrow that you may or not be able to down. It says down, so I have to put that disk online and then initialize that disk. And once I do that, I should now be able to make a new simple volume. And I'm going to make it really big, 250 meg. Huge. And now it says here, before we just assigned it a drive letter and kept going. Now we're going to mount it to the following NTFS folder. And I can go into C and go down and find my really cleverly named mount folder. Or you can create a new folder here also. And say, okay, next. And I'll call it mounted. And perform a quick format, and you notice this one in the server is not the default, just so that it is a quick format. Now when I go back to the C drive and the mount, it's got a little shortcut symbol, and I have the pathway to get there. And it doesn't give me any information because it's a mounted drive. It says the target is mounted, so you're not going to see a whole lot of information about that one. But those are the basics, how you do each of these things. So mount volumes, create a disk management console. Different mount points can point to the same target partition or volume, which is kind of interesting that you can do that. Symbolic links. This is something that you used to have to go put a piece of software in. Symbolic links, again, just links something to somebody. You've done that in Linux. The symbolic link just sends you someplace else. Well, it is kind of a fancy shortcut, isn't it?
Yeah. Can you partition your C drive too much where it will mess up your operating system?
Can you partition your C drive too much where it'll mess up your operating system? How about if I say yes and no? Depends upon a lot of things. One, if it's a basic disk, you're limited to how many partitions? 4. Okay. What you want to be aware of on the C drive, the operating system drive, is that Windows has to consistently come back to that. Okay. You really want to, as much as possible, leave it alone on its own physical drive. Okay. You also would prefer to put your page file on a different physical drive so that you're not doing paging and disk reads for the operating system on the same controller, the same communication channel. So all of those, are those going to be significant for my Windows 7 machine? No. For your Windows 7 machine? Maybe. For a server? Quite possibly. So, I mean, you got to really look at how much disk access are you having when you do those things. But could you? Yeah, if you got a lot of reads and writes on that same disk, absolutely, you can slow down the operating system. None of the system files, but the system files are going to be protected in its own partition. And we've got tools to go back, and we looked at those too, right? The system files to go back, the system file check. I get because I've got another Windows class at night. They're a little bit different pace, but there is a piece of software that they have called the System File Checker that checks your operating system files to be sure that they're undamaged, and is supposed to repair them if they are. So you have those tools available also. A lot of new tools, a lot of tools available in this that you may or may not have ever heard before. The sparse files, I know I kind of skipped over that because we have this one. Large portions of sparse file contains no data, just zeros in the data. What this does is allows the space occupied corresponds only to the non-zero part. And you can, I think, see that when it says a file size and size on disk. That's kind of related to those sorts of things when you go through. So theoretically, you get more space, but in practicality, in non-theory, Windows is always going to run out of disk space. True? Honestly. And that's where the mounted files come in. If you run out, yeah, you can put a new disk in, you can do a mounted file, and you can do stuff, put stuff from your C drive to some other location and keep it space. I've actually never tried it. You can with I have actually too, because I plugged in a USB drive, yeah. But remember, if you remove the media, you made a mess. So yeah, you can, but yeah, maybe not necessarily a good reason, a good system to do that. It's also going to have to be NTFS. When we do those things. So, yeah, maybe not. Universal disk format, optical storage. And these are ones that we really don't have a lot of control over because you get a CD, a DVD, the optical media, it's got its own file system. It does support UDF as one of them. It also supports CDFS, the CD-ROM file system. And when you write files, it creates these file systems for you when you use a CD or a DVD creation software. CDFS, compatibility with older CD-ROM. UDF is the new file system for those media. Extended FAT, used by the manufacturer for large portable memory devices. You know, your 64 gig flash drive, those kinds of things. Again, flash drives are typically going to be a FAT file system. Recommended for volumes of 512 terabytes or less. Anybody got a 512 terabyte flash drive? Terabyte flash drive?
Yeah, 4 or 5 of them.
4 or 5? Oh, you got 4 or 5 on them. Bring one in. What would you like to see?
No, No.
It's 512 terabytes.
I think Ryan's got like a USB that's got like a huge.
It's huge, but it's not. It's not that huge.
He's
It's
got
not 512
No, he's
half
got
an
that
exabyte.
fancy-
terabytes, and I bet it's not even a terabyte.
No, it's some kind
Yeah, well, it's a USB 3, and that's what he's really proud of about it. USB 3, and it is much faster.
Yeah, but he's got some kind. It's like it's got an enormous amount.
Yeah, it has a lot of storage. I agree. He had it in the other night. It is, but it's not that big.
No.
Terabyte flash drives. Has 7 terabytes.
I haven't seen it.
Costs you about $3,000.
They would be very expensive. Native support with the XFAT and Vista Service Pack 1, and hopefully from the other class, what have you determined? You probably have determined about Vista that you really don't want to use it. The only reason you want to use it is go through it to get to Windows 7 from XP, right? It really had some issues that this one doesn't. We can change the drive letter and converting the install file system. And converting the install file system means you can go from FAT to NTFS. Once you convert it, there is no unconvert. You can't convert from from NTFS to FAT. You can only go from FAT to NTFS. And that's just a matter of going to the command line using the convert command. Convert the file system. The drive letter asks you some questions that if you don't know the answer to, you can just go back and look at the disk properties and find out those answers. This can become an issue, probably not anymore, but in older systems can become an issue when you actually ran things from the CD. And if you created a new partition, it changes all the drive letters, and now your installed programs don't run because it can't find the CD. It's looking on your new volume or whatever for those things. You can go back and swap the drive letters around so that it fits what you want it to fit instead of what Windows is necessarily going to do. And that's just a matter of going into the volume and change the drive letter. If you're going to go to one that exists, when you change a new volume to the E and E is already taken, you got to go to some letter that doesn't exist and then go back to what you want. It's just a matter of moving that around until you get to where you want to do it. And that's in the disk management console. In here, assign the following drive letter, and when you install these things, probably have noticed you can assign whatever drive letter you want, or you can tell it not to assign a drive letter. Occasionally, and I think it's when the virtual machines, everybody's doing a lot of stuff at the same time, occasionally these virtual machines will not assign a drive letter. If you see that happen, just go back into the disk management and give it one. It's just, I think that the server gets so busy that sometimes it says, oh, I did that, but it really didn't do that, or it did it here and it thought it did it there, kind of deal. But occasionally you'll see that happen. Converting, and these are the steps. Back up the data. That's always the first step for everything in a file system, isn't it? Back up the data. This usually doesn't fail, by the way. Reformat a partition with FAT or NTFS, we really don't want to do that. This one, you would have to back up the data. Restore the original data. Is that the best way to do this, do you think? Huh? No, it's not the only way. Convert the partition using the convert command.
No, to go from NTFS to FAT.
To go from NTFS to FAT, absolutely, that's the only way. I'm sorry. Yes. To go from FAT to NTFS, oh yeah. Guess I should look at my own slide, huh? To go from, but why would you want to do that? I guess that's why that doesn't even register. Why would you want to do that? Really?
The legacy system.
Legacy system? Maybe. If you're going to dual boot something, yeah. But the only way to go from NTFS to FAT is to format it and do that. To go from FAT to NTFS, use the convert command. Test will ask you all of the specific. It's convert like :NTFS or file system NTFS, on and on and on. If you're actually doing it, you don't have to remember all that stuff. All you got to remember is that Windows will tell you what to do. Convert / question mark will give you the rest of the syntax, just like everything else Windows, right? It'll give you the syntax. Sometimes it's not as easy as other times in order to get that syntax to work. But there is a syntax: convert drive ID C:// /FS:/NTFS. Tells it what we're going to convert and what we're going to convert it to.
Would the ID be in?
ID is just the drive ID, C:.
I thought so, okay.
Yeah. The convert utility, you got to run it as administrator. So in your systems, if you just run CMD and run the command line, it ain't going to work. You got to right click it, tell it to run it as administrator. So the command prompt does have to be running as administrator. And to do that, even if you do the start and then the run line, CMD, when you get the symbol up, right click on it and tell it to run it as administrator. You don't have to go into, or you can put a shortcut on your desktop. You don't have to go into the accessories every time you want to start a command prompt. It's there. It finds it readily. Folder and file attributes, these are the ones that I guess kind of sort of take a little time. The file and folder attributes are going to be specific depending on whether we're sharing. I'm going to go through these and I want to go through what this looks like really quickly. Actually, I think what I want to do is, instead of trying to try to use a notepad with some larger letters here on what we actually have in the file systems themselves. When we do permissions, we have a couple of different things to consider. The first thing to consider is the file system, and the file system can either be FAT or NTFS. That's it, right? And where do the permissions apply? Well, in the FAT file system, actually let me go back up here. We got two types of permissions: share and NTFS. And when I say, where do you think the NTFS file system, the NTFS permissions apply, what are you going to say? Which file system? NTFS. That's it. So they, and I guess I can only tab over. So NTFS permissions. In the FAT file system, we can only have share permissions. NTFS, we can have NTFS, and guess what? Share. What share does is when I right-click on a folder and share it to whatever, whoever, and the default is going to be, the default share permission is going to be read to everyone. What that says is you can see that across the network. But you can't do anything to it yet. Exactly. So if I were going to do that, let's say RKE, what is our storage, right? Is it storage or storage 1? I don't remember. I guess it's storage. So now we can see all the shares here, and we got a whole bunch of shares, and you can do the same thing and see the shares. Can you use the shares? That's where the permissions come in. So I can go in here and double-click on the RN program, since I'm not an RN program kind of person, and it says that you do not have permissions to access that share. Just because I can see it doesn't mean I can necessarily use it. Oh, by the way, if we wanted people to not use it, we'd put a $sign after the share name, and it doesn't show up. It's still shared, it just doesn't show when I go to the browsing mode here.
What do you mean? You say put it after it, or?
After it, yeah. I'll show you that just in a second. We got a bunch of shares here, huh? Student apps. The one that's got a whole bunch of stuff on it that you may or may not be interested in. It's got all these PowerPoints and things like that on it. Department heads, continuing ed, goes on and on and on. Admissions, Taylor, some of the admissions people up there. I'm not going to go there because some of these things I have permissions to from when I was the network administrator. Some of them I don't. Student home. Look at there. You can do that too. And you can see all of the student home directories, but you should only be able to open yours. And we'll go through how we get to that here in just a second. So the share, the remote, the share, and the permissions are going to be, remote, can't spell, can I? Remote or local. Remote means that I access it across the network. And actually, NTFS is going to be local and remote. It gets involved in a little bit of everything. And then we have a permission that we used to call deny or no access, and deny means deny. That means that when we get into one, we're going to have one called full control. And full control means you can do anything. You're like administrator, right? I can give you full control in 47 different places and give you one deny, and you can't get there. The only way to take an explicit deny, and we're going to call it explicit because we're going to have one called an implicit deny in a minute. An explicit deny, which means that I go to the file system, and I want to go back to my virtual machine because I can't do everything on the desktop. They don't trust me. Can't blame them, huh? If I go into give permissions, let me get back to full screen to get that out of the way. To give permissions, and let's make a new one here, call something clever like demo. And I right-click on it, and we can go into share. This is the new and improved sharing system. We can go through that. We can add, go in here to the drop down, and we don't have a whole lot of users on this machine, so we can add everyone and share that resources. Demo, Win2K8 base, because I haven't changed the machine name, is now going to be shared. And when I do that, we have this little symbology here, which used to be a clever hand. It's now this little symbol that I haven't really figured out what it is anymore. Used to be a hand in the old system. So if I go to / 127.0.0.1, because I don't remember the name, this is the machine that I just shared this on. So I have my folder here called demo, and I can get into it because I shared it to everyone, right? Everyone means everyone that's on that machine, by the way. Who can see it? Everyone means everyone when you get into who can actually see these things. So we can, if I quit closing the wrong stuff, come back to this thing. I put that on C, didn't I? Demo, we shared it. Properties, if I go back in here now and sharing, I can do the share. If I do advanced sharing, which is the old-fashioned way, share this folder and look at permissions, I can now see the users and which permissions it has. I can add demo. This is a different sharing. The administrator, who is me logged on, has everything. I can add users in here in order to configure this thing. To me, this one may or may not to you, but since this is what has been used forever, this to me is the real easier way to do that. I think it didn't take my other. It did take my share.
It did, but you didn't add everyone.
I didn't add. It did because aha. Thank you. I didn't add everyone. I showed it, but until you say add, you don't really do anything. But so in that case, let's go back to the advanced sharing, if I want to now add demo to this, actually let's go back and do the permissions. If I want to add everyone, and when you do these things, they have you type out everybody. You can start the name and then check names, and it's going to go find the unique character string for you. So I can now add everyone, and when I add everyone, again, the default permission is read. This can cause you some issues, because if you're a member of the group everyone and you're not the user administrator, and now you want to write something, save something to that folder, you can't do it because you can only read there. The typical, and this is the older version, I think 2003 changed. Before 2003, the default permission was to share it to full control to everyone. Is that dangerous?
Yeah.
You think so?
Yeah.
I don't. How's that? And I'll show you why in just a second. Because we had the permissions, the share permission does what? Allows you to see the share. We can now control access with the NTFS permission, because on this other thing here, whatever permission I give, we get the most permissive, or the permission that we get is going to be the most permissive. Individually, when I put the share and the NTFS permissions together, I get the most restrictive. So if I go back to this thing and I have this, I've given full control, then I go into my permissions, properties, security here, permissions, and if I then add everyone, and we check the names and we get these guys, and I give them read, execute, and read. When you go remotely, you have the read permission. When you go locally, the NTFS permission, you have the read permission. So those two, when they get put together, you get the most restrictive permission. Okay, let's go back to the permissions. When we had this, we didn't have allow selected, but we didn't have deny selected. The explicit deny I was talking about is if we went over here and clicked on this. When I clicked on full control, it just denied everybody everything. Guess who was also a member of everyone? Administrator. Let's see if this worked. Let's see if I've lied to you. So let's go back and double click on it, and it says, boy, I just made a big mistake, right? Usually they'll tell you you've done something, you're about to do something really dumb, like the user that we had that was disabling the user administrator with no other administrator on the machine. It says, you're about to do something really stupid. Not literally. Are you sure you want to do this? And she said, yes. Absolutely. Now then, I've got this server that I've got to destroy. Not really. Because if you go into safe mode, it disables the policies. But you need to make those things. So if I really messed up, goes back to, I don't have permissions to get in, but who's the owner of this thing, you think? Yeah, I've been denied. Okay, I got it. But if I go back to properties and in security here and edit this thing, I can change the permissions because I'm the owner. And since I'm the owner, and you can find that if you go into advanced, it tells you about auditing. Owner is administrator in the administrators group. So owner can always change permissions. Administrators can always take ownership. So if you go in and at your file system out here on the server, your home directory, and try to deny the administrator, all he's got to do is go and take ownership, give himself permissions back. So you can always do that. You can't give permissions or give ownership, permissions. You can give permissions. You can't give ownership because the basic answer to who's the owner is whoever created the file or the folder. And my example is always that somebody has downloaded a bunch of pornography or child pornography and they don't want to be responsible for it. They give you ownership. They can't do that. You can give the authority to take ownership, but you actually have to take it. And when you get back to disk quotas is based on the number of files that you own, the size of the files that you're marked as the owner of. So if you have a very limited disk quota, what you can do is talk your buddies into taking ownership, and then you get your disk quota back. And the user administrator doesn't get quoted because he owns basically everything on the machine that individuals didn't create. We also have, since I've used the term explicit with a check mark, an implicit deny. This explicit deny was pretty bad, right? There is a thing called an implicit deny, which is what actually works on your home directories. An implicit deny says that if I give an individual permissions to a folder and don't give it to somebody else, then that individual that got it, and the individual that didn't got it, don't got it. You're denied. Your implicit deny is you're denied because somebody didn't give you positive authority, then you're denied. The advantage there is that instead of having to go back and uncheck that explicit deny, if I wanted to deny a bunch of people's stuff, all I got to do is change the permissions. And we talked about groups, and no, we didn't. We talked about groups in the other class. What we're normally going to do is manage users in groups, which is the best way to do it. We have a separate lesson on groups. And you can change the permissions simply by changing the group membership of a user. So the explicit permissions, if I had a bunch of users on here, and I maybe gave the user John permissions to that folder and didn't give permissions to the user Ken, John would be able to get there and Ken wouldn't. But that has to be an NTFS. And you notice that in the FAT we had, 3 permissions and the deny. Explicit denies are very dangerous because the only way to get rid of an explicit deny is to go back to it and take it away. If you did it today, you'll probably remember it this afternoon. You may remember it next week. Yeah, the odds are getting slimmer that you'll remember it next month, but the odds are almost 100% you won't remember it next year. Or when somebody takes over, you go get the better job and somebody else comes in to do your job. The odds are they're not going to know about it. Why can't this user who just got promoted can't get into the resources that they need to do their job? Now you've got to go back and hunt down that explicit deny. Implicit denies are a much safer way of doing things. Does that make any sense going through the permissions? When you put what does a share permission do for you? What does it do? It can be used in the NTFS or the FAT file system, which means going back to Windows 95, you could actually share resources. Allows you to see it across the network. When you go directly to the console, when I went to this console, did the FAT file system ever show up when I was on this system? It only is effective when you access a resource across the network. The NTFS file system permissions apply to both local and remote. And hopefully we demonstrated that just because you lock yourself out, if you have the authority to give yourself permission, you can give yourself permissions. Administrators can take ownership of these things. When I put together these things, and when I do, so let me go back. When I do them individually, I get what's called the most permissive. They call them additive, most permissive, whatever else. What that means is that if you're given read in one group, we'll talk about groups before we get there, and full control in another group, you've got full control. When I put them together, if I have full control FAT and read-only NTFS, when I access it across the network, I have read. When I access it locally, since it's an NTFS permission, I have read. So you actually fine-tune or manage your permissions using the NTFS, not the FAT. That's why I say when they changed it, it's now read-only. It gets me all the time because I'm used to it. I just share it, and then I put myself in it, give myself NTFS full control, and golly, I can get there. Golly, I can't get there. Because when I put my full control NTFS and my read-only FAT, I have read-only. You got to go back and modify the share. And you can see the shares, and we demonstrated that just because you can see the share doesn't mean that you can necessarily get into it. We'll do one other thing while we're here. You saw that when I went to the //. You saw that that was there, right? It's already shared. Advanced sharing. So this share name is demo, and we actually went in there and made me use it, right? Let's start over. This new one drives me nutty, by the way. So what I want to do is share. Let's stop the sharing of this one. And now let's go into share. And let's share it with everyone and actually add them this time. And share this thing. It has a name. We're done. I'm not any better off than I was, am I? I want to rename the share. Change the sharing permissions. They've made this more difficult than it used to be. There we go. Sharing. I should stop this one. We can add a share name here, and let's change this one to my share $. Maximum allow, we'll just do the users. The permissions on this one, and let's add everyone here. And let's give them full control since we've determined that that really doesn't affect a whole lot, right? And say, okay, so this one is named my share, right? So if I go back to 127.0.0.1, I get my, hopefully, list of shares. Maybe I don't get my list here. Oh, because I got too many zeros. You guys let me give this a 5-octet IP address. That doesn't work real well, does it? The 4 octets work better. We still got demo, but my share is not there. Do you see my, I know it's starting to see from where you are, but do you see my share there? The $sign after it makes it a hidden share. Can I get to it? You think? If I go to, and the / universal naming convention tells us we're going to get there, 127.0.0.1, and then the / the share name, which was what, my share, $, then it opens that folder for me. It's still there, it's just not visible to everybody. So you can use that to share resources but not advertise the resources with the hidden share, with the $sign function. So permissions. The thing that, I don't know, is the most, I would say the most complex, but not really. It's just a matter of just like doing subnetting, taking it one step at a time. What do you want? Do you want hosts or do you want networks? What do you want? We want to share it. Okay, I want to share it. I've got to right-click. I've got to share it. I'm going to give it a FAT permission. If I have the FAT file system, that's the only thing I can do. Say again? FAT permission. Actually, share. Share permissions can be used on, and I probably wrote that wrong, but share permission. Share can be used on both the FAT and the NTFS file system. And what does share do for you? It shares the stuff. it allows users to access it across the network. That's it. When you log on to the console, it has no impact, only NTFS file permissions. And when we combine the share and the NTFS permissions, we get the most restrictive permission. So I actually can share it with full control to everyone. And then if I only want James to have it, then I would go into the NTFS and give it to James.
NT has priority over fact.
No. When you put them together,
Okay.
you get the most restrictive permission between the share and the NTFS.
Okay.
When I do them individually, I get the most permissive. Sometimes you'll hear it as additive, which basically means that you get whatever the highest level permission you have any place in the system. But when you put them together, you get the lowest level of whatever you have. So if I gave full control to everyone and then only gave the NTFS to read to James, what would Josh have? Really?
You said only to read.
Only to read. I gave full control to everyone in the share.
Okay.
I didn't complete the statement, I guess. And I gave read to James in NTFS, and then I accessed it across the network. What are Josh's permissions? Did I give Josh any permissions? This is where the implicit deny comes in. James would have read, right?
Yeah.
What would Josh have?
I guess nothing.
Nothing, because I didn't give him anything.
Fair enough.
It's like if somebody brings in a bunch of candy bars, and they give Josh a candy bar, and they don't give Maurice a candy bar. How many candy bars does Maurice have? Zero. How many does Josh have?
0.
He's got a candy bar. So we implicitly denied Maurice the candy bar, right? Because we didn't give him one.
Okay.
Does that make any sense?
Yes.
And the permissions work the same way. That's what the implicit deny is. If we start giving permissions and we give it to somebody and they'll give it to somebody else, the somebody else doesn't have any. This is the folder you're going to see, files ready for archiving, allow this file. Compress and encrypt, you notice here are checkbox looking arrangements, but you can only do one or the other. You can compress or encrypt. You can't do both. Because if you compress, you're going to destroy your encryption key, because you try to compress the encryption key. These are the things that we have just finished, so we can click through them, right? Apply changes, and this is just nice things. Apply change. When you change something, do you want to apply the changes to everything or just this area? Apply changes to this folder and to subfolders and files. If you only want to apply it to the folder that you're in, you can do that. If you want to apply it to the whole directory structure, you can do that. The attribute flags, read only, these are the same attributes that you had in DOS. And you can change them at the command prompt with the attrib. Attribute flags, we've kind of looked at this, I think, in the view. If you go all the way to the bottom of this thing, that's where you turn on your administrative tools. Was that right? They've done a couple of, I think, odd things, because hide file extensions is the default. You don't necessarily want to do that. One of the tricks that a hacker will use is to send you a file with a lot of spaces in it, like virus.txt 10,000 spaces.exe. If you have the file extensions hidden, you'll never see the exe. So you can turn that off. A number of things here, and then don't show hidden files is a default. Don't let me see the system files, and that's probably pretty good for users, not going to be necessarily good for administrators. Sometimes you want to see how big your page file is, for instance. You have to allow yourself to see those files, and experiment with these things as you go through. Turn them on, turn them off. Just remember that, don't go trying to destroy the system files, because it'll get really mad. And if you do all this, you say, I want to go back to the original, you have a restore default option. Archive, hidden, system, all ones that you've seen before, right? Compress, we've talked about, only supported with NTFS, and again, all of the clever stuff, all the good stuff is only going to be NTFS. When copy and compress files, the compress attribute of the file becomes the same as the target folder's compression attribute. Copying, just like the permissions. If you copy a file from one location to the other, you get the permissions of the destination. Encrypt, only supported on NTFS. A folder or file that's set to encrypted can't be compressed. You can only do one or the other. An encrypted file will remain encrypted unless the encrypted attribute is disabled. So once you encrypt it, it's going to stay encrypted. Or saved on a volume. That's what I said. That was my thing. Hey, I'll just move all this stuff to DOS partition and it'll unencrypt it. Yeah, you got it. You got to be the one that has the authority to decrypt it. So if I encrypt something and you decide that you want to use it, you're not going to be able to decrypt it because it's going to ask you for the certificate in order to do that. File and folder permissions, access control list, default. We've kind of looked at that. The first level of the NTFS is the root folder. The default permissions are inherited. You get certain permissions all the way through the file system. They come from the root, // If you look at // they're going to be certain permissions. Inherited permissions are going to be grayed out. You can't change them. It's kind of odd. So I guess we need to go back to the other thing. See if I can mess that up, huh? And how you would, what if you want to change it? How would you do that? So if I go in here and make a demo 2, and I may have already changed some of these, and go to Properties, Security, Creator Owner. You notice this is grayed out. Users is grayed out. What if I want my users to all have full control of this thing? I just go into Edit like I did before, right? Edit, and go into Users, and I can't do anything. I can add to it, but I can't take those permissions away. If you want to change that, go to Advanced, Edit. This says Include Inheritable Permissions. Uncheck that and tell it to copy the permissions. Once you do that, it's supposed to, if I did it right, those are now not inherited anymore. Those are explicit permissions. So the inherited permissions are kind of going to be the grayed out ones. The explicit permissions are going to be the more distinctive black color when you get to things. And you can't take away an inherited permission. You can only take away explicit permissions. Symbolic links were introduced in Vista. Actually, if you went and got the software, went and got the third party, they were introduced in XP. Sparse files. How did I get back to there? That's not where we were, is it?
Yeah, we were on slide.
We were way down.
We're on slide 44.
I must have 2 of these running. Let's get down to 44, which you're a lot happier with than 23, right? Me too. So we've looked at the default permissions, and the default permission for both FAT and NTFS is basically read. The NTFS is read and execute, which means that you can open a file, or if it's an executable, you can run the executable. That's really mad at me, isn't it? It's because I'm in the wrong format here. Let me that was what the jump, when we get a file system, they call it jump, and that's the wrong one, and we don't want that one. But we've already done a number of these already. The default folder permissions are basically read and execute. Members of the group, the default permissions, and hopefully when we went through that little demo, this made the individual permissions, if you look at them, it'll tell you explicitly what you can do. Each permission builds on the one before it. So if I have write implies read. As you go up that list, because I think you got read and then write. If you got the one above it, and if you click on them, it'll give you all those permissions below it. Modify. Yeah, modify actually, to me, the way I remember modify, it actually lets you modify the header permissions, the header properties. To give users permissions, you need to be an administrator. You have to have administrator authority to give somebody else permissions to a folder or file. And we have file permissions and folder permissions. Again, they're basically the same. File permissions override folder permissions. The answer to that's like everything else in Windows. The closer you are to whatever you're trying to control, that permission is going to be the one that's active, that's effective. Read and execute, modify. Same actions as read and write, and execute, permission, provide, and then we go up to full control. Full control allows the user to take ownership. Full control allows you to give permissions. Special permissions, and when you're doing these, just take a look in there. What special permissions are more precise, and you can go in there and actually become much more precise than the general permissions. These general permissions are normally going to be satisfactory when you do those. We talked about fine-tuning, and that's what we do. 4 file types, scopes limited, this folder only, and this is at the top. What permissions you're going to, this folder only, this folder and the subfolders, this folder and subfolders, and on and on and on. The way that we did, and I think we still do, when you create your home directory, and you created your home directory the first time that you logged on, you had create permissions in that folder. You created one, but inheritance didn't happen. If we allowed inheritance, you created it, everybody's going to inherit permissions to your home directory, which we didn't want. So that when you get into these things, they're there. You should know them. They're probably a little bit beyond what we actually need to do in this class as far as permissions go, because what I'd really like for you to do is understand NTFS and share and how they work together, how you actually control the permissions. Inheritance we looked at. Inheritance can be blocked. We can turn it off by going into the advanced and unchecking that one. Effective permissions can be inherited or directly assigned. We've seen that. The effective permissions are the combination of everything. And if you have no access, what's your effective permission going to be? If you have no access, what's your effective permission going to be? Nothing, because we didn't give you a candy bar. Right? And there is an effective permissions tab which came about in 2003 server, which really is handy. You can go to the user, the effective permissions, and you select a user that you want to find the effective permissions on that folder. Much easier than the calculation that you used to have to do. We talked about ownership, and what's the real key to ownership? If I own it, I can give permissions to it. I can give myself permissions to it even if I don't have permissions to it. And you can change ownership in the advanced. You can give permissions for somebody to take ownership of your. Yes, if you own it, can you give other people? Yes. Administrators can do anything. Administrator does everything. Permissions, when you move or copy, and again, the basic rule here is if you copy it, you inherit the permissions, and if you move it on the same volume, you retain the permissions. And those are there are lots of places that go through lots of different rules, but that's the basic, simple rule of this thing. Okay, copy. What's the difference between copy and move?
Copy leaves the original intact.
Copy leaves the original intact. Move moves it. It's no longer at the original location. Huh?
In some cases, can't they do the same thing?
No.
No.
Move is actually a cut and paste. Cut when you cut, and that's everybody talks about cut and paste. Now everybody's cutting and pasting. They're really copying and pasting. Because cut means that you take it away, or move means you take it away from the original location and put it in a new location, be it text in a document or a file system. But
remember when it was in Word, sometimes it'd be a line that say.
yeah, I know that, but they're not. I know they always say that. My wife uses cut and paste, and I just quit saying no. You're running me a copy because she gets mad at me.
Yeah. So there isn't a cut in Linux. It's all moves, isn't it?
There is a move in Linux.
Right. I mean,
Yeah, but no, you cut. Yeah, you cut. That's the move.
No,
Yeah.
there is no cut in Linux.
You're right. There is a move, but there's not a cut. Yeah. But this is a Windows course. Yeah. Newer versions will inherit permission settings of the target location. So copy, when we copy, anytime we copy, it's going to inherit the permissions. And again, if you want to visualize it, maybe not a good visualization, but visualize it going through the folder and getting its permissions as it goes through the folder. When you move, see they got all this stuff. Move, basically, it's going to keep the permissions unless you move it to a new volume. And the reason that is the only thing you do when you move something is change the pointers in the directory structure. So the permissions are going to stay the same. It really doesn't go anywhere. But if you move it to a new volume, it's going to go to the new location and inherit the permissions as it goes through there. The best practices, and you can read those. Best practices, folder structure, pay attention to your folder structure. Yeah, for you and me at home, it's probably not that big a deal, but if you're doing lots of sharing, it can become a bigger deal. The previous versions, Windows 7 has that now. To restore the previous versions of a file, it takes snapshots on a schedule that you can specify of those. On the local computer, generated by backup or shadow copies. What shadow copies does is it allows you to back up an open file, which you never could do before. But that's part of shadow copies and backups, part of a different lesson. Tracks the changes so that the snapshot you can actually go back to a previous version of it. Now, when you immediately save it, you're not necessarily going to have a previous version. You got to wait till the snapshot has been taken. If you have one, you go to the previous versions, it's going to show you what's there. You can replace it. What people typically are going to do is copy it and put it into a new folder, because generally what you're going to be looking for is a file that, I really didn't mean to overwrite that file. If you got a previous version, you can do that. So what are the two permissions types that we use in here? What are the two permissions that we talked about? NTFS and share, right? And when we put them together, do we get the most permissive or the most restrictive? Most restrictive. Individually, we get the most permissive, or whatever the highest level is. The file systems that are available on Windows 7, bulk storage, FAT, NTFS, UDF, and we have backward compatibility with the CDFS file system. FAT, unless you got a good reason to use it, you really don't want to go there. Drive letters and mount points we looked at allows the support for larger partitions, alternate data streams. Alternate data streams can be good or bad. Sparse files kind of get back some of the space in files that really aren't being used. You can use symbolic links stored in FAT and NTFS partitions. Use attributes to control and limit file access. All of the clever stuff is only available in NTFS. Copying. If we copy, what's going to be the permission? What's always the permission if you copy? The folder that it's going into, it's going to inherit permissions. Move, you're going to inherit permissions on a new volume. Otherwise, you'll keep the existing partitions. And until you shoot yourself in the foot doing that, you're going to say, not a big deal. Previous versions of a file. Questions? You're probably just ready for me to quit now, aren't you? Questions. Permissions are, and Ken was talking about that, permissions, he said, can't be overemphasized, and I think that's probably true. Permissions are probably one of the quickest ways to get yourself into some really big trouble. Not because you didn't give somebody permission, but because you gave too much permission and you shared the company's secrets with the world. If you don't give enough permissions, people are just going to come to you and complain. You can fix that. It's when you've given too much and nobody tells you. And you find out that for the last 6 months you've been sharing the faculty home directory to students.
Yes. What?
That happened. Nobody noticed, though, because you guys don't try it out enough. Actually, that happened. We found it. I typically will do, and we may do it a little bit later, have you go to the shares and tell me what you can get into. Can you get into somebody else's home directory? Can you get into my home directory? How do you test this stuff? That's the way you test the stuff. Just because you go in and put it in, does it work the way you thought it was going to? Maybe. How do you find out for sure? Go create yourself an ordinary user and see what they can do. Can the student get there where he shouldn't be? So, check them, check them, check them. Because I won't say that Windows changes things, but sometimes everybody says, "Oh no, I didn't do that." You know, nobody ever does any of this stuff, right? Nobody did any of this stuff, but all of a sudden you have these resources shared that aren't supposed to be. They're supposed to be shared, but everybody's got permission that they shouldn't have. So something happened. Somebody did something somewhere. It's like users that say, "Oh, the computer doesn't know what my password is. Computer's got my password wrong." Odds are kind of much against that. Questions?